Hello, welcome to Last Minute Maths again. And in this video, we're going to go through the June 2022 EDEXCEL Maths Paper 2, the higher tier, and it's a calculator paper. As always in my videos, I'm going to use each of the questions as a little revision opportunity, just to explain the solution and remind you of any key points that you need to remember for your exam. And as always, any questions, any comments, or a particular topic you'd like me to cover, please leave it in the comments and I'll be happy to do that for you. And if you haven't already subscribed, then please click the little red button on the bottom right corner. It's free, so please do subscribe. And let's launch into the paper itself. All right. So question number 1, law of indices. Again, I've got a separate video explaining the whole of the law of indices. Laws of indices video, and you can check that out for revision. As a rule, when you have x to the power 3 here in this case, and then raised to a higher power, so the whole thing is to a higher power, then you multiply the powers. Okay, you can see 3 times 5. So the answer is x to the 15. All right, there we go. Part B, expand and simplify. All right, so simplify simply means collect all like terms. So in these questions, you are multiplying the factor on the outside by everything in the brackets, one by one. And you're doing that twice. So you've got 4 times x, 4x, 4 times 3, 12, so plus 12. And then in the second bracket, you've got 7 times 4, so 28. And then 7 times minus 2x, so minus 14x. Combine all of that, 12 plus 28, 40, and 4x minus 14x minus 10x. Hence 40 minus 10x. Next one, part C, factorizing. All right. Some of you will do this just by looking at it, but just again as a revision, the way to think about it, if it's something that you're not clear about, then 15 times x cubed can be broken out into its factors. In other words, break out each term into all the bits that are multiplied together to give you 15x cubed. So you've got 3 times 5, factors of 15, and then you've got x times x times x. Same thing for the second part. 3 times x squared times y is 3 times x times x times y, etc. All right. Now from here, we want to pick out the things that are common to both terms. All right. So you've got a 3 in each of them. All right. Then you've got 2 lots of x's. So for example, that one there, and there, and there. So those are the only ones that are actually common to both. So take those out. All right. Effectively, 3 times x goes on the outside. Put some brackets in. And what you're left with are the bits here. 5x plus y. Don't forget that they are separated by a plus. All right, so you've got to keep that in there as well. All right, so your answer turns out to be 3x squared times 5x plus y. All right. Question number 2. All right. This is a translation because you are moving it. All right. Moving a shape equals translation. Right. The shape doesn't change. The orientation, meaning which way up it is, doesn't change. Everything else remains the same, just the position changes. All right. So that's a translation. Best way to do these is to pick a corner, right? Any particular corner if you like. And I've taken that one there. And we see where that corner goes to. All right. So it's gone. As you can see, I've labeled it already. It goes 6 up so that's plus 6, and then it goes 5 to the left, to the negative direction on the x-axis. All right, that's why it's minus 5 in the x direction, and that leads you to the same corner. All right. In translations, you have to answer it in a vector form, like that. All right, has to be a vector. You don't get the full marks. It's actually a 2-mark question, and it's got to be in vector form. Translation vectors are always given. X is the top number, and the Y movement is the bottom number. All right. So as we've already seen, it's 5 to the left, so that's minus 5. So that's the X movement. And it goes 6 up. So that is the Y movement. All right. So remember, with translations, you've got to put it in vector form. Right. Number 3. Length of a football pitch, 90 meters, correct to the nearest meter. All right. That's important. The error interval, if it's completed the 90 meters is like nearest a whole meter, then the maximum it could have been is like a shade under 90.5. If you hit 90.5, it would become 91, all right? Whereas 89.5, okay, would be rounded up to 90. So that basically is your error range. I mean, if you think of it like this, 90, maximum 90.5, and minimum 89.5. All right? Fairly simple. Number 4. Festival A will be in a rectangular field with an area of 80,000 square meters. All right, so there's information there. And the maximum number of people allowed will be 425. All right. Similar data for Festival B, except this time they give you the measurements of the field, all right, and give you the number as well. So what they're asking for is the area per person, all right? That one there, area per person for each one of those, and to compare. It actually tells you that Festival B has a greater number of, or greater area per person than A, and they want to know how much greater, all right? And they want the answer to the nearest whole number. So this is what we're doing. The total area divided by the number of people, the maximum people allowed. So for A, we've got straight away 80,000 square meters, and the maximum number of people, 425. Okay, so that's that one there. And that comes out to be, roughly speaking, 188.235, etc. All right, whatever comes up on your calculator there. For field B, or festival B rather, the field dimensions are 700 times 2000. So multiply that out and you get 1.4 million. So 1,400,000 square meters divided by 6,750 people. And that gives you a value of 207.407, etc. meters per person, square meters per person, that is. So taking the difference, B minus A, it gives you 19.17, all right? And that, to the nearest whole number, remember, is 19. Right? So there's your answer, 19 square meters greater for Festival B. And then part B of the question is a statement. 300 square centimeters is the same as 3 square meters, all right? Because there are 100 centimeters in 1 meter, so you divide by 100, etc. It's wrong, definitely. Explain why, and simply to say 1 square meter is 100 centimeters times 100 centimeters, all right? And that means 1 square meter is 10,000 square centimeters. And so 3 square meters would be 30,000 square centimeters. Just put that in. You don't have to write a statement for this particular one. Right. Number 5. The points L, M, and N are such that they are all on a straight line. Okay. And just as a schematic, let me show what's going on here. So imagine you've got L and you've got M and you've got N. All right. So on a straight line. And then they give us the coordinates of L and M. So we know L, we know M. And then they give us a ratio of the distance from L to M to the ratio of M to N. So that's actually 2 to 3. All right. Okay, how are we going to use that? The ratio, if we start with that, LM to MN, so the first part to the second part of the line, is a ratio of 2 to 3, as given in the question. In order to turn that into an equation, we cross multiply. All right. And so effectively we get 3 LM equals 2 MN. All right. And just swapping that around a bit, therefore take the 2, divide on the other side, and you get MN equals 3 over 2 times LM. All right, so 1.5 times LN. That's effectively what you want. All right, put a times there. Right, so now we need to work out the movement from L to M, and you use the coordinates. All right, coordinates of L are -3, 1. M is 4, 9. All right. So going from L to M, 4 minus -3 is 7. So you're going X is 7. All right. Let's put an X. And the Y movement is 9 minus 8, which is that. Okay, Y. So the vector for L to M, all right, remembering back to a couple of questions ago, the vector format is 7 across and 8 up. All right. And just write that. All right. 7 across, 8 up. That's fine. We're now going to use that. We know that going then from M to N is 1.5 times as much. So whatever we did going from L to M, we are then going from M to N, and that's going to be 1.5 times. So whatever this is 1.5 times it. All right. So 1.5 times that vector, 7, 8. All right. Use your calculator if you wish, mental maths, whatever appeals to you. So 1.5 times 7 is 10.5, and 1.5 times 8, 12. All right. So the movement from M to N is 10.5, 12. Again, that's 10.5 across and 12 up. All right. So the coordinates of N are effectively going to be the coordinates of M plus the movement vector that we've just worked out. All right. So remember M, just remind you there, had coordinates 4, 9. So we're going to add the 10.5 to the 4, 14.5, and add the 12 to the original 9, so that's 21. So the coordinates of N are 14.5, 21. All right, so let's just write it like this. And remember, they want coordinates, not a vector. So it's got to be written horizontally. All right. Okay, hopefully that's clear. Number 6. This is a compound interest type of question. All right, so same as compound interest method, except this time you are decreasing the value. Oops. There we go. All right. So what they're saying, new phone costs £679, and the value of the phone decreases at a rate of 4% per year, as you can see. All right. And they want the value after 3 years. All right. So the first thing we do is work out what we call the multiplier. All right. And just to highlight what that is, it's basically 1 plus or minus the change, the rate of change in percentage in decimals. All right, that's your multiplier. And the rate in decimals. Okay, all right. So 4%, right, we need to work out as being 0.04. All right, so 4%, remember percent is 4 over 100, so 0.04. All right, so the multiplier, in this case, it's a decrease, so it's going to be a minus. 1 minus 0.04 gives us a multiplier of 0.96. All right, bring that down there. And effectively what we're doing is taking the original value, 679, times 0.96 times 0.96 times 0.96. It's just decreasing each year by the same rate. All right, so 0.96 cubed for short, put that in your calculator, and you get the full value, as you can see. In this context, it makes sense to put it into like whole pence at the most. So 600 pounds and 74 pence. All right. Probably not worth putting in any more decimal places than that. It's meaningless beyond a penny. All right. Number 7. In Spain, Sam pays 27 euros for 18 litres of petrol. And in Wales, Leo pays £40, 80 pence for 8 gallons of the same type of petrol. So in other words, they're saying it's the same stuff, and you've got two different ways of expressing the price. They then give you this conversion from euro to pounds and also litres to gallons. All right. And Sam thinks that petrol is cheaper in Spain than in Wales, and is he correct, etc. Now, you can do it any which way. You can calculate, for example, keep it as euros per litre, and then convert the values in Wales to euros and then to litres. You could keep it as euros per gallon, pounds per gallon, whatever you choose, as long as you are consistent and you work out the same values for both. All right, I've chosen pounds per litre. All right, so in Spain, we know that the amount paid is 27 euros, and we know that each euro is worth 0.85 pounds, so 85 pence. Okay, so if we multiply that by 0.85, we get 22 pounds 95 pence paid for the 18 litres. So the price per litre, like this, is 22.95 divided by 18, and that gives us 1.275. So I know I've kept the extra decimal place, but let's say it's 1.275 pounds per litre. All right. For Wales, the same calculation. We already have it in pounds. All we need to do is convert the gallons into litres. Remember, it takes 4.5 litres for 1 gallon. So 8 gallons times 4.5 gives us 36 litres. So the pounds per litre is the 40.80 pounds divided by 36 litres, and you get 1.133 pounds per litre. All right, with or without the third decimal place, which probably doesn't mean much. We can tell that Sam's comment that cheaper in Spain is wrong. All right, so in this type of question, you've got to write a statement. Just doing the calculation on its own is not sufficient. All right, what am I doing? Hang on. Okay, so make sure you write a statement. Okay, otherwise you won't get the answer mark. All right, hopefully that one's clear. Number 8. Okay, use your calculator. Now, obviously, when I'm doing it on screen like this, I can't show you what to punch into the calculator, but what I can do is point out one thing you have to be careful about. This 7.2 to the power half, which is in the denominator, is the same as square root of 7.2. All right. So when you're putting it in your calculator, I would advise, to avoid any mistakes, right? Start with the brackets, then put the cube root sign in, then the 1.57 and to the power 4 plus tan 60. Remember to close the brackets. The calculator will automatically open the brackets for you after the tan. Close the brackets and then close the brackets again to match up, all right? And then that whole lot divided by square root of 7.2. All right, so please do use brackets just to make sure that the right things are added and the right things are divided, etc., etc. All right, the order in which you put things into a calculator can make a huge difference. All right, so the answer comes out to three significant figures. You've got 0.73933, etc. So 0.739. All right. Number 9. A box in the shape of a cuboid placed on a horizontal floor exerts a force, as we can see, of 180 newtons on the floor and exerts a pressure of 187 newtons per square meter on the floor. And they're expecting us to use that formula there. All right. So what do they tell us after that? It's the length, all right? The amount of area actually covered by the box on the floor is 1.2 times x, all right? So that's area equals 1.2x. Starting with the formula they've given us, pressure equals force over area, rearrange that, multiply both sides by A, so you get AP equals F, in other words, area times pressure equals force, and then divide both sides by P, move it across the other side, and we get the formula that we're going to use, which is area equals force over pressure. Just to be clear. Okay, and put the numbers into it now. So we know that the area is 1.2x, and that must equal 180 for the force, 180 newtons, divided by the pressure, which is 187.5 newtons per square meter, and that gives you 0.96, all right? So very simply, we've got 1.2x equals 0.96, and so x equals 0.96 over 1.2, etc. And that gives us an answer of 0.8. So x is 0.8, and they haven't bothered putting the meters sign, but that would be meters. All right, that's already understood. Right, number 10. Box plots. Shows information about sales in thousands of pounds of an online store, all right, each month, etc. And just to revise, I think just give a quick revision of this. That's the lowest value. That's the highest. That is the median. And that is the lower quartile. And that is the upper quartile. All right, that's how a box plot works. And the statement says, Andrew says, 3/4 of the given data lies between 160,000 and 350,000, because these are the values of the lower and upper quartile, etc. Andrew is wrong, they're saying. Explain why. Simply, it's a one marker. All you have to say is that between the upper and lower quartiles, which is the interquartile range, covers 50% of data. All right. So I've put in between upper and lower quartiles is 50% of the data. You could easily write interquartile range covers 50% of the data, etc. All right. or you can contradict the statements by actually using values on the box plot. All right, enough said on that. Just a bit of quick revision. And in the second part of the question, they're giving us some data about a different shop, all right? And for this one, you need to draw the box plot. So what we've done, the least value, 30, so that's there. Then you got the lower quartile, 80, that's there. And median, 170, that's about there, all right? Upper quartile is 260, it's about there, and greatest value 350. All right, so all of that has been plotted, and we've done the sort of the whiskers, the box and whiskers thing that you're expected to do. So 2 marks for that. And then they ask you compare the distribution of the sales of the online store with the distribution of the sales in the shop. Just to remind ourselves very quickly, the online shop, you can see the range is from 60, and these are all in thousands, remember, to 420, all right? And the median, for example, I'm just going to put that in, is at 200, okay? Right, and for the second one, we've got the data in the table, all right? So just to polish the question off, you need to write a comparison, right? It must be a comparison. You can't just state the numbers. You have to say which one is greater, which one is less, etc. So to be safe, put online store has greater range of 360,000 than shop, which has range of 320,000. All right. So it's that greater or less than, whichever one you want to put it. And then the online store has a higher median of, again, comparison of 200,000, sorry, than shop, which has median of 170,000. So make sure you put in a comparison, and where possible, state the actual values, all right, to make sure that you're safe getting the 2 marks. Okay, next one is one of those sort of scaling a job up or down. Kieran has 13 workers he can use for a job. He knows that 6 workers would take 14 and a half days to complete this job. All right, so they're giving you all that data. Show that Kieran has enough workers to finish this job in less than 7 days. All right. First thing with these questions, always work out the total number of days or the total number of hours, whatever the question is based on. So in this case, you've got 14.5 times 6 workers. All right. And so the total number of days is 87 days. All right. If he then spreads the 87 days worth of work across 13 workers, here, 87 divided by 13, the number of days required, therefore, is 6.692, etc., which effectively comes to 6.69 days. So we've demonstrated that it's less than 7 days. All right. Okay. Number 12. It's all about y equals mx plus c, all right? And remember that the m bit, right, that is the gradient. In this particular case, we want to show that these 2 lines are parallel, okay? So if they're parallel, means same gradient. All right, so that's what we need to show. All right, so we're going to start with line 2, okay? Its equation is 5y minus 10x plus 4, as you can see, equals 0, all right? We want to rearrange this and get it into the y equals mx plus c form to make it easier. And so move the minus 10x and the plus 4 to the other side. On the other side, they reverse their signs. So you get 5y equals 10x minus 4, and divide everything by 5. So you get y equals 10 over 5 times x, minus 4 over 5. And simplifying that, you get y equals 2x minus 0.8. Okay, compare that with line 1, the equation y equals 2x plus 3. They have the same gradient, we can see. It doesn't matter what the plus c minus c, whatever that is. The gradients are the same, both of them 2x, etc. And again, you need a statement. Okay, so remember to do that. And all you need to write something simple. L1 and L2 both have gradient of 2. Simple as that, all right? Right, number 13. Now this one, I haven't done any annotation other than what's in the question, and I'm going to explain it now. What they want is that you do an enlargement of a shape by scale factor minus 2, and the center of enlargement is the origin, all right, 0, 0. So center of the enlargement is there, okay? Now, here are the key factors. With a negative scale factor, means other side of center of enlargement. Okay, and it also means shape gets inverted, i.e. flipped upside down. All right, okay, the way to do these ones is what I tend to do is to pick the sort of two widest parts, two corners of the shape, right, as far apart as possible. So there, that one there, and I've picked that one there, all right, and draw a line, nice long line, connecting, for example, I'm going to call that corner there A, all right, and this corner here B. Hopefully you can see that on the screen. So connect corner A through the center of enlargement, right? That one is the center of enlargement, and just extend it as far as you can on the graph, all right? Do the same for a line joining corner B through the center of enlargement, and again, just going as far as you can, all right? So, you know, corners are vertices, so if you want to call it a vertex or vertices, that's fine. Now, having done that, okay, remember it's a negative scale factor, and then the scale factor itself is 2. So you could, with your ruler in the real exam, just take a look at how far it is from A to the origin and the center of enlargement, and just measure off double that, exactly double that, and see where you get to, all right? And same for B to the center of enlargement, and then again, double that distance with your ruler, and you'll end up with the new vertices. So this one is A, and that's B, all right? Those corners there. You could, as an alternative, count off squares. So for example, A is horizontally 5 squares from the center of enlargement and 2 squares down, or 5 across, 2 squares down. So you just go 10 across the other way, right? And 4 up, okay, etc. So that's an alternative method. But if you do the intersecting lines through the center of origin, then that probably is adequate with the ruler. Just make sure you measure out the distances correctly. All right. Any concerns on that, questions, whatever, please leave it in the comments and I can do a separate explanation of that. All right. So number 14. Saffron wants to work out an estimate for the total number of fish in a lake. It's one of those questions where you catch fish or bees or sheep or whatever it is and mark them somehow, put them back in the population, and then catch a few more, see how many there are. So initially, Saffron catches 150 my apologies, 180, and puts a tag on each of the fish and puts them back in again. A day later, catches 305 fish, okay, of which 45 are tagged, all right? So what that means is the 180 have spread out in the population so that they represent 45 out of the 305, all right? It's effectively been spread out, and we'll tell you by how much. The way to work this out is to say, well, we put in 180 originally, right, with the tags. Second time round, we've only got 45. So we've got 45 divided by 180, a quarter of them, so 0.25, all right? The ratio of the fish, the tagged fish, all right, to the population, etc., has to be the same. In other words, we assume they've been distributed evenly, all right? So the 305 to the total, therefore, okay, must have the same ratio, all right, or same fraction, if you like. So 305 divided by the total must be 0.25 as well, all right? And if you just rearrange that, move the total across to the other side as a multiplier, move the 0.25 to the left-hand side as a divider, right? So as a denominator. And so you end up with 305 divided by 0.25 equals 1220. All right, so that's the total population of the fish. All right, hopefully that's clear. Number 15, all right, the ratio of Marta's hourly pay to Khalid's hourly pay is 6 to 5, right? Then they get an increase. Now both of them, right, get an increase. So £1.50 extra per hour for each of them, okay? After the increase, the ratio becomes 13 to 11, all right? Changes from 6 to 5 to 13 to 11. And they want us to work out the actual hourly pay before the increase. That's the important bit. All right. We're going to start with a statement that says the ratio of Marta to Khalid, sorry, M to K, is 6x to 5x, all right? Then it changes, right, when they get the 1.5 hourly increase. Marta to Khalid, the ratio is 6x plus 1.5 to 5x plus 1.5. And we are given that that ratio is actually 13 to 11. All right, so that's stated there. Okay. As said earlier in the video on a previous question, in order to turn that into an equation, you cross multiply. Okay, so 11 times 6x plus 1.5 in brackets equals 13 times 5x plus 1.5. All right, so expanding that out, you've got 66x plus 16.5, and that equals 65x plus 19.5. Okay, I want to put all the x's on the left-hand side and all the other numbers on the right-hand side, all right? So when we rearrange that, you got 66x minus 65x equals 19.5 minus 16.5, all right? So x equals 3, all right? And putting that back in, remember we had that. So Marta gets 6x, which is 6 times 3, 18. And Khalid gets 5 times 3 equals 15. All right. So Marta's pay 18 and Khalid's 15. Done. Right. So next question, 16. I've left this one blank because I actually wanted to work on it live as we do it, because to explain exactly how to put these questions together, several of my students have asked about this and how to interpret the details. All right, I'm going to try and keep all that on the screen at the same time. All right, so what we have, it says shop manager, special offers, blah, blah, media platforms, asks 100 customers which type that they use, whatever media platform it is, okay? The results he gets are summarized as you've got in that list. Now, I'll talk you through this. 4 use all 3 types. So that straight away goes in the middle. All right. All 3 types, A, B, and C. 16 do not use any of type A, B, or C. So they go on the outside. All right. 8 use both type A and B. So that's A and B, but not type C. So that we're effectively excluding the C altogether. All right, so that has to go there. Can't go in any of the other boxes. Then we have 14, use type B and type C. Now, this is the reason I wanted to do this question separately. All right, that does not exclude the A, all right? Right. So does not exclude A. In other words, we know that there are 14 that use type B and C, right? They might use A as well. The question doesn't, the statement does not say anything about not type A, as it did in the previous one just above it, all right? So we know they need to be in B and C, so it's that one there. And the total is 14. We already have 4 there. All right. So that's got to be 14 minus that 4, 10. Okay. Don't put 14 in that box. It's got to be 10 because the total is 14. Then we have 62 in total use type A, and that includes people using, for example, type B and type C. All right. What else we've got before I put that one in? All 20 who use type C, all right, also use at least one of type A and B. All right. So that means that there's nobody using type C only. No type C only. All right. So that is 0. Okay. Better to leave it just blank. All right. And then it says all 20. So we know that the circle containing type C has to have a total of 20. We already have 14 there. So that leaves us with 6. All right. So the 6 must go into the leftover bit of type C. All right. I hope all this is making sense. Now we come back to the thing about A. 62 in total use type A. Well, we've already got 8 plus 4 plus 6, all right? That's 18, okay? And so from 62 minus 18, 62 minus 18, all right? 44. There. So that is just about all of that. Now, the one bit that we are missing is that having done all those numbers, remember we have the total equals 100, and we know that we have 62 in A, then we got another 10, which is 72 plus another 16, all right? So 72 plus 16, 88. So we're missing 12, and the only place those 12 can go is in B, all right? That completes the actual Venn diagram and how to structure it, all right? So if you leave it like that, I've done a lot of explanation, but if you just put the numbers in, you can see how that's been achieved. The next part of the question, and I'll keep that on screen there, says one of the customers is chosen at random, given that, now this is the important bit, right? Given that this customer uses type A, all right, that means that the person is in, we're already in circle A, all right? So inside circle A, oh, let's see if I could, oh, excellent, there you go, lovely circle. Find the probability that this customer also uses type B. doesn't say anything about not type C, okay? Can include C, right? It doesn't say anything about that. Now, of the A, right, we know that the total of A is 62, and of those, ones that use B are the 8, all right, and the 4, okay? And on this side, we've got 44, and the 6, etc., okay? In fact, you know what? I'm going to get rid of that last bit there. All right. So we know that the bit of B that we have has 12 in it. All right. So there are 12 people who use B out of the 62 that use A. All right. So that effectively is your answer. Right. You can simplify it if you like and divide whatever 6 over 31 if you wish. All right. Whatever is equivalent. Probably better to leave it like that, I think. Doesn't matter which way. Excuse me. Right, so hopefully that also makes sense. Watch out for the given that statement. That's what's important. All right. Okay, number 17. Now, this one, the examiners really annoyed me with this. It's a significant amount of working to do and not a huge amount of space left. I mean, I don't know what they were thinking. So what they're telling us, we have this funny looking shape with half a sphere and then a cone popped on top of it. All right, so I don't know, wobbly shape. Okay, it's three-dimensional and it's solid. All right, so the diameter of the base of the cone is 7, as shown, and the diameter of the hemisphere is 7. In other words, they match exactly. All right. And then they're telling us that the total volume of T, meaning the complete shape, is 120 pi, 120 pi, all right? And the total height, as in the diagram, is y, from the base all the way through to the top of the cone, all right? Now, one thing, therefore, we need to understand is that the volume of the cone on its own must be the total volume minus the volume of the hemisphere. All right, so we're going to use that as the way to solve this particular question. Okay, remember you've got the formulas given to you. Volume of a sphere, 4/3 pi r cubed, and volume of a cone, 1/3 pi r squared h. All right, bear those in mind. Now, it says calculate the value of y. All right, so what we're going to do, and 3 SF, 3 significant figures. First, we're going to start with the hemisphere. Because of this thing here, we're going to work out the hemisphere details. The radius, you've got to notice that the diameter they refer to both times. So the radius is 7 divided by 2, 3.5. Okay, so the volume of the hemisphere is 4/3 pi times 3.5 cubed. Okay, normally I would write this in some sort of form where you've got, I don't know, some multiple of pi, but I think it's easier to just to put it in the calculator and get it over and done with. So that volume of the hemisphere is 89.797 dot 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 dot, etc. And then the cone, right? We know now, this is important. The cone height of it is y minus the 3.5. All right, so y minus the 3.5, and that's the bit that we want to use. So this is y minus 3.5. Okay, so the height of the cone, y minus 3.5. The volume, therefore, looks a little bit daunting, but don't be put off. 1/3 pi times 3.5 squared times the height of the cone itself, which is y minus 3.5. What I've done is calculated the numbers on the outside of that bracket, leaving the brackets alone. All right, so it's 12.82817. That's all that was on the calculator. Okay, so using the statement, the volume of the cone is total volume minus the hemisphere volume. Okay, so we're just putting all those details that we worked out in one place. So there we are there. 828.17. No, say that again. 12.82817. There we go. Get it right second time. Times y minus 3.5 must equal 120 pi minus the volume of the hemisphere, which was 89.797, etc., etc. I haven't bothered writing out the rest of the numbers. And that comes to 287.194. All right. And therefore, if I rearrange it a little bit, ignoring the bit in the middle, so you got y minus 3.5 must be the 287.194 divided by the 12.82817. All right. And that gives us a value of 22.3877, etc., etc. All right. Many other numbers. And remember, that is y minus 3.5. Okay. So if we add the plus 3.5, we get y equals 25.8877, etc., etc., to three significant figures. You want to round it after that 8, so you get 25.9. All right. Okay. Yeah, do take a look at that. I had to cram all that into a short, very small space there. All right, part B. The diameter of the base of the cone and the diameter of the hemisphere are both increased. Basically, the shape gets wider. So instead of being like that, right, it's sort of like maybe a bigger circle, all right? To keep the same volume, right, assuming the total volume of T does not change, then, well, you've already got a huge amount in the hemisphere itself. So that means you don't need to go quite so tall with the cone, all right? So explain the effect this would have on your answer to part A. The height of the cone, y, in fact, I should probably correct that. Just say y would also decrease, all right? And I think height of the cone, y minus r, or y, would decrease. That's the important bit you need to get in, all right? Total height of the shape would decrease, the height of the cone would decrease. Right. Number 18. Okay, this one, you've got irregular triangles, so scaling triangles, etc. As soon as you see angles and sides, think cosine rule, all right? And that one is a squared equals b squared plus c squared minus 2bc cos a, all right? Cos angle A. And the important thing to note is that angle A corresponds to a squared. So if you have a shape, triangle like that, let's say this was angle vertex A, so there, this would be side A. So the angles are opposite, all right? So in that respect. So what we're going to do is set up a sort of relationship. We want to find this side here, okay, QS or SQ, what do they call it, QS. But we don't know anything about it except the angles. In fact, we know all three angles, but we don't know any of the sides, all right? So in order to work out the length of a side, okay, we have to know at least one length, other length, to be able to work it out, to use the sine rule, all right? And the sine rule, remember, is A over sine A equals B over, sine B equals C over sine angle C, etc. All right. So in order to do that, we can't find this one, right? There's no information helping us with that one at all. The one that we can find is this one here. Okay, RQ, QR, whatever you want to call it. All right, so we can use the cosine rule for that triangle PQR and find the length of RQ. All right, and they want us to work, I give our answer in 3 significant figures at the end. Okay, I'm putting in the values into the cosine rule. Okay, this is my angle A, so that's going to be my side A. All right, and 11 and 9.4 represent my B and my C. Okay, so using the formula, RQ squared equals 11 squared plus 9.4 squared minus 2 times 11 times 9.4 times cos 27. So that's effectively cos A, angle A. All right. Putting it all in your calculator, we get these numbers. It's always good practice to write out parts of your calculation if you can, right? If you've got the time to do it. Simply, it helps in case you get an incorrect number or a number that you think is impossible. It's easier to go back and correct and see where the mistake is, all right? So I've got 209.36 minus 184.26, and that gives us a value of about 25.099. Now I've kept that there for the moment. So RQ, all right, is the square root of that. So that's equals square root of 25.099, etc. And that comes to 5.0099 and other digits. Okay, now use the sine rule, as we've just seen. So remember with the sine rule, the angle, the sine of an angle is directly related to the opposite side. So the ones we're using are going to be the angle 41 to the one that we've just found, like that. And we want to find QS there. So we're going to relate that to angle 88, all right, like that. So going back to it, RQ is opposite to the angle 41. So RQ over sine 41 must equal the one we want, QS over sine 88. Multiply the sine 88 across to the other side and put the numbers in. Okay, as you can see, 5.0099 dot 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 divided by sine 41 times sine 88, and we get a value for QS of 7.6318, etc., etc., and 3 significant figures, so the answer is 7.63. All right, okay. Functions now, and again I've got some practice function questions in another video, so alongside other topics and things. All right. Okay, we're given two functions. G of x looks actually worse than it is. It's a cube root of all of 2x minus 5, and h of x is simply 1 over x. All right. So first thing they want us to find is g of 16. So basically put 16 into the function g. So wherever you see an x, replace it with 16. So inside the cube root, we've got 2 times 16 minus 5, so 32 minus 5, 27, cube root of 27, 3. All right, so there's your answer there. Then they're saying find h of the inverse of g of x. All right, and it's really important that you pay attention to that and write it out with double brackets. Okay, so what effectively we're going to do is to find the inverse function of g of x, okay, then put that into h, all right? Okay, so finding the inverse of g of x. So what we do is we replace the g of x with a y, all right? So let y equal cube root of 2x minus 5, okay? Cube both sides, and you get y cubed equals 2x minus 5. Move the 5 across to the other side, y cubed plus 5 equals 2x, y cubed plus 5 divided by 2, so we're going to divide both sides by 2, and you end up with an expression that says x equals something to do with y, function of y, right? And then you swap, okay? Swap the x and y, and that effectively gives you y equals, or the inverse g, equals x cubed plus 5 over 2. So replace the y with the x, all right? So we get an inverse function of g. So inverse of g is x cubed plus 5 over 2. Now we're going to put that into h, all right? And remember, h is basically 1 over whatever we put in it, all right? So 1 over something simply means flip upside down, all right? Very mathematical term. And all right, yeah, to be serious, what it means is it's a reciprocal, all right? The reciprocal of whatever we put in. So that's why we flipped it upside down, and that becomes 2 over x cubed plus 5. All right, so there's your answer there. All right. Number 20. Again, I've left this one blank. I wanted to actually talk through it as we go along. And I'm going to work through the question first and then talk through how to write it out. All right. We want to find this angle as I've already annotated. Okay, they want us to find CDE and giving a reason for each stage of the working. All right. Always start with what you know. All right. In this case, we know the angle at the center is 132. All right. So if we know the angle at the center and the same points, B and D, all right, are then joined to the circumference, i.e. at the edge, all right, then we know that this angle is going to be half the angle at the center, all right? And so that is going to be 61, all right? Oh, what have I said? Bear with me. Okay, 66. Try that again. Right. So once you have that, we can now see that we have in this shape here a cyclic quadrilateral, right? And that effectively, let me just write this out. Okay, in a cyclic quadrilateral, opposite angles, right, add up to 180. All right, and so that's what we need to use for this. All right, so if this is 66, then this angle here, okay, that one is going to be 180 minus 66, and that equals 114. All right, so 114. Okay, so 114 there. And remember, this is a straight line there. All right, so that, right, put the thing back in. So this angle here must be 66. All right, because that's 180 minus 114 now. And this triangle, we effectively have a 16 and a 66. All right, so what does that make it? 82. All right, so remember, total has to be 180. So 180, this one here, 180 minus 66 plus 16. And that's 180 minus 82. And so 98. All right. Okay. The way to then, for those of you who understood what's going on and you know how to write it out, you can move on to the next question. But I will write it out properly. So the specific way to write it, okay, angle I have to keep flicking back and forth here, BAD equals 66, and the reason for that is angle at center is double angle at circumference. Okay, and then the next thing is angle BCD is 114, and you can show a calculation, I suppose. 180 minus 66 equals 114, and the reason for that is cyclic quadrilateral, right? Let's see, so quadrilateral. Opposite angles add up to 180. Then you got angle DCE equals 66. Angles on a straight line. And finally, angle CDE equals 180 minus, and all you have to write is 66 plus 16 equals 98. All right, and here angles in a triangle. There we go. That literally is all you need to do. And there's your answer there, 98. All right. Okay, moving quickly on, almost done. So question number 21. You've got a graph of y equals f of x and shown, and then you are transforming it into y equals f of minus x, right? That is effectively a reflection in y-axis. So you're flipping the shape side to side. So just flip it over to the opposite side of the y-axis, which, as you can see, I've done. All right. Okay, the next part of this question is actually a bit surprising. I mean, they've done the same sort of thing, but made it just look more complicated than it actually is. We're starting with the y equals tan x graph, all right? And God knows how many times I've told my students, make sure you know the trigonometric graphs, sine, cos, and tan, all right? Because you need to know them in order to be able to label these lines here, the asymptotes, okay? Asymptotes. Right. They've got a graph, it's translated, all right? Remember, translation is moving something into a different one, which is y equals g of x, okay? Following the translation, the point Q, so that one there, shown on the graph above, moves to point R, excuse me, where R has coordinates 90, so 90 degrees, and a value of minus 5, all right? So look what's happening. First of all, what I've done is labeled the various points that are important here. So we have 90 there, we've got 180 there, 270 is the second asymptote, and where Q is, effectively that's at 360, all right, as I've labeled. Okay, so we want Q to move to 90, all right? Now, if you move left, okay, that is f of x plus a, all right? It's counterintuitive with the x's, right? Some of you might think you move to the left, it's negative. It's not. It's got to be x plus a. So we know that this thing is going to be f of x, and we want to move from 360 to 90. So that is a move of 270. So x plus 270, all right? And then we know that originally q was on the x-axis, all right? So the y value of the coordinate was 0, okay? So originally q is 360, 0, all right? And so it needs to go down by 5, okay? That means that the y value needs to go down by 5, right? It doesn't have anything to do with the x. So that goes outside, all right? So for example, f of x plus a goes up by a, and let's just do that. F of x minus a goes down by a units, all right? So in this case, we want to go down by 5, so you just put a minus 5 on the outside. So the answer is tan of x plus 270, which moves it left by 270 degrees, and then outside of the brackets, minus 5, which moves it down 5 units on the y-axis, all right? Okay, almost there. Last question, number 22, says find algebraically, all right? And even if it says algebraically, you're doing the algebra, but use little sketches, because what we have is quadratic inequalities, all right? So inequalities in general, all right? So the first one, use difference of squares, and we've got x plus 7 times x minus 7 is greater than 0, all right? To help yourself understand which part of it you want, right, which region of the graph you want, you are allowed in these questions to do a little sketch for your own benefit, all right? It's not something you're doing entirely graphically, you're doing the algebra to go with it, so that's absolutely fine. As long as you do that, then that's all you need, all right? And I think it's difficult to do these entirely in your head. So make sure you do a little sketch like that. This one, very simple, quadratic. And we know that it goes below the x-axis. And that point there is 7. That one there is minus 7. We want the bits of the graph which are greater than 0. In other words, above the x-axis. All right. So anything in between the two, they're below. So we don't want the bit in between. So in other words, like that, we want that, we want that, we don't want that. All right, that's greater than 0. Actually, I better not put that in that particular position. This bit is greater than 0. That bit is greater than 0. This bit in the middle is less than 0. All right, and so using that, the range of values for x which is valid is x is greater than 7 and x is less than minus 7. So those are the two conditions we get from the first one. The second quadratic, all right, just looking at the numbers, it may be quicker, save you time in the exam. Use the quadratic formula. And again, how to do that, there is a video on channel on that. Quadratic formula, how to use it. Okay, if you need to revise that at all, do take a look at that. All right, so we're going to just use the formula. I've put the formula here for your benefit, and that's A is 5, B is minus 31, C is minus 72. All right, if that's confusing in any way, please do watch the other video, and that might help you. So putting the numbers into the quadratic formula, I've got, oh, hang on, I've made a mistake there, I think. Minus b, no, that's fine. Minus b effectively is minus 31. All right, so that's why it's positive 31 there. Plus minus, and put everything into the square root. Minus 31 all squared comes out to be positive. then times minus 4 times 5 times minus 72. So that actually comes out to be positive, right? All divided by 10, which is 2 times 5, okay? 2 times a, in fact. So working all that out, it comes out to be reasonably nice numbers, actually. 31 plus or minus 49 divided by 10. And that actually gives you two roots. If you were to solve for equals 0, you'd get 8 and minus 1.8. All right. Again, a little sketch. Okay. And all you need to do is to mark the values. So you see, if you look at it like that and like that, these are the bits that we want, greater than 0. So you have to be greater than 8, right, on this side. So x is greater than 8. Oh, sorry. 8. And on this side, x is less than minus 1.8. Now, we have to take areas that satisfy both statements, all right? So in this case, 8 is further on the right-hand side. So we need to keep the x is greater than 8, all right? But from the previous one, we know that x has to be less than minus 7, okay? That works for both of them. Less than minus 1.8 doesn't satisfy the first statement. So effectively, we get one limit from each statement, and we end up with that. X has to be less than minus 7, and it has to be greater than 8. All right, so those are your answers there. All right, well, there you go. That's the whole paper. I've tried to do it as quickly as possible. And if there are any topics you'd like me to go over again, any questions, comments, suggestions, always welcome. And please do subscribe if you haven't already, and watch out for more videos as we go through exam season. And I will be doing more papers, plenty of other topics and papers covered on my channel. Do check them out. Thanks very much for watching, and good luck with your exams.